All right. Hello, my name is Lorenzo Riano. I'm a research engineer at Bosch Research and Technology Center here in Palo Alto, and this is one of the exciting projects that we're working on. So nowadays there is plenty of tools to acquire 3D data. However, this 3D data has a lot of problems. It's always noisy, it's not accurate, and above all, it's very hard to interpret, to segment, and to extract meaningful information. And our specific scenario is, if we acquire 3D point clouds of indoor buildings like houses and offices and venues, how can we extract meaningful data out of it, like where the wall starts, what is the size of the room, and so on. For the data acquisition, I think you're sort of familiar with the Google Tango project. For those of you who haven't heard of it, it's a mobile device that is capable of tracking its own position, and it's also capable of acquiring 3D data. And Bosch is one of the partners of the ATAP Tango project, and we have the small mobile phone that you see on the top left, and we also very recently acquired the tablet that you see on the top right edge. And that is the main tool that we're using for this project for acquiring 3D point clouds. And the main advantage is that since the Tango knows its own 3D position and orientation, it helps a lot in aligning the data and creating sort of coherent point cloud from several snapshots in large buildings. So since we are in a robotics group, we went on using our favorite tools for Tango, and we created ROS wrappers around the Tango API, and we also created off-board and on-board computing using our favorite libraries like PCL and OpenCV. And we also managed to run a live demo during ROSCON 2014 a few months ago, which worked surprisingly. And all the code is available open source on our GitHub repositories. Okay, so back to our original task. We start with a collection of rooms or buildings in 3D acquired using several techniques, and we built this tool to do a segmentation of the data. And let's see. So this is a tool that we have developed. You can see we can visualize the data, we can segment meaningful details, like you can see the ceiling on the top, and at the bottom you'll see the walls that are automatically extracted from this data. It is very, very challenging problem because these are not empty rooms. These are rooms with furniture, with clutter, and also this furniture covers the entire wall, so it's very hard to estimate the correct dimensions of the wall. And our requirements are that this is not a toy, this is something that people will have to use for real work, so it has to be extremely accurate. By extremely accurate, I mean to the order of the millimeter. This is the kind of problems that we're dealing with right now. She also point out that this is right now the work of some people and my intern Serkan, who's sitting over there. All right, I think I'm in the 5-minute slot here, and we are a research center. We are open to collaborations. We are seeking partners, both in academia and in industry, and we have several levels of partnership that you can work on. So if you're interested, please come talk to me afterward. Thank you very much.